elegant design and outstanding running properties, this is how the new M40 engine will present itself to its public from September 1987. The M40 will be fitted to the 318i. What are the objectives which BMW have pursued in the development of the M40, the successor to the M10? Optimal layout for the 1.8-litre capacity, use of the most up-to-date electronics in the four-cylinder engine, greater power output and improved torque, plus compliance with the most stringent limits on exhaust emission, minimal difference in output between the versions with and without a catalytic converter, service-friendly with reduced maintenance. Before we take a closer look at the technical innovations and the most important servicing jobs, here's some data on the engine. The M40, with a capacity of 1,786 cc's, delivers 83 kilowatts or 113 horsepower at 5,500 RPM. Its maximum torque of 162 Newton meters is attained at as low as 4,250 RPM. Let's start with the construction of the engine. Like every engine, the M40 consists of the engine block with crankshaft, conrods, pistons, the cylinder head with camshaft, inlet and exhaust valves, intake manifold, and exhaust manifold. But what's new? The crankcase is stiffer and shorter. The cylinders are cast together. This gives a reduction in the distance between the centres of the cylinders from 100 mm to 91 mm. The crankshaft has been redesigned. It runs in 5 bearings and has 8 counterweights instead of 4. The pistons and conrods have also been further developed. The recessed crown of the piston forms part of the combustion chamber. The stamped arrow indicates the installation direction, and the stamped-in number the diameter of the piston. The oil pump drive has also been optimized. The pump is driven directly from the crankshaft. The flywheel too is new. It's designed as a dished flywheel. The dished flywheel with its greater mass means a more even running momentum of the engine. The new design of the cylinder head is based on the M70. The valves are arranged in a V formation. The angle between the valves has been reduced in comparison with the M10. This means that the combustion chamber can be more compact. Larger diameter inlet valves are used to optimize cylinder filling. Sodium-filled exhaust valves are used for better heat conduction. In order to achieve a dynamically stiff, low-vibration valve drive, the camshaft runs in 5 bearings. In the M10, if you recall, it runs in 3 bearings. The bolted bearing caps on the one hand facilitate fitting and, on the other, achieve optimal weight saving. Dual valve springs ensure reliable valve operation whatever the speed at which the engine is running. Instead of the rocker arms used in the M10, the M40 uses drag levers for valve operation. As on the M70, the drag levers are guided on one side by hydraulic valve clearance compensators. The use of these hydraulic compensators mean you no longer have to adjust valve clearance. On the other side, the drag lever rests on a sliding block. The camshaft is driven by a toothed belt. The distributor rotor arm is driven directly from the camshaft. Now we come to the intake system. The two-piece intake system has swept-up intake pipes. This makes it possible to increase the length of the intake pipes, again helping to optimize cylinder filling. This produces increased torque in the low and medium engine speed ranges. The throttle butterfly connection is housed in the upper section of the intake system. As on the M10, the throttle butterfly is cable operated. The air volume metering principle has also been retained. A single coil rotary valve is used for idling control. One important innovation is that, on the M40, a third-generation Motronic is used. The basic functions of the Motronic remain unchanged. As you know, the Motronic receives information from various sensors and uses this information to control injection and ignition timing. Ease of servicing was an essential development goal for the M40. Let's start with the oil filter. It's easily accessible from above. One important point: when changing the oil with the filter, in order to ensure that all the oil is drained, it's essential to remove the oil filter housing cover bolt before the oil is drained. Only then can the oil in the filter housing drain off into the oil pan. As you've already seen, valve clearance no longer needs to be adjusted, since this task is performed by the hydraulic valve clearance compensators. These are the new special tools for the M40. You'll find information about them in the repair instructions or service information. Proceed as follows to adjust the valve timing. Locate the crankshaft at TDC using a mandrel and the camshaft using the locating tool in position valve overlap on cylinder 4. Install the belt and adjust belt tension with a tension roller. Comply with the specified torque setting. Then tighten the camshaft wheel to the specified torque setting. After you've removed the alignment tool, turn the engine over several times. And check camshaft-crankshaft coordination once more. The water pump is easily accessible and easy to remove. You can see that maintenance has been substantially simplified on the M40.